Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today's presentation is prepared for a brief description of basic concepts relating to set theory. These concepts are particularly useful to understand and deal with the problems of probability. The theory of sets was first introduced by German mathematician George Cantor in the later part of 19th century and proved remarkable things about sets. Sets are used to define the concepts of relations and functions. The study of geometry, sequences, probability requires the knowledge of sets. Studying sets help us categorize information. It allows us to make sense of a larger amount of information by breaking it down into smaller groups. Set is an important mathematical tool that is useful in many branches of mathematics, including probability. In this presentation, you will learn to describe and illustrate well-defined sets and its types. You will learn to define and describe the operations on sets. You will learn to explain the concept of Venn diagram and to solve problems involving sets. The concept of a set plays an important role in the theory of probability. This role lies in the fact that the use of concepts, notations, and terminology of sets gives a better understanding of the theory of probability. Some elementary concepts of sets are therefore discussed in this presentation. Let's recall what is a set, what are its different types, what is a Venn diagram, and what are operations on sets. What is a set? A set is a well-defined collection of distinct objects. For example, a set of all people living on the earth, a set of teachers in a college, a set of students of statistics, a set of vowels of the alphabets A, E, I, O, U. The objects that constitute a set are called the elements or the members of the set. A set is usually denoted by the capital letters, whereas the elements by the small letters. A set may be expressed in any one of the two ways, a tabular form or a set builder form. In a tabular form, we write a set by actually listing all the elements of the set. For example, set A is equal to Batul, Mansia, Simab, Sarish, Iza, the students of second year. Set B consists of 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. These are first 10 odd numbers. And set C consists of 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. These are first 10 prime numbers. And set D consists of A, E, I, O, U, the set of vowels of the alphabets. These sets can be written in a set builder form by describing the type or properties of the elements of the set. Set A consists of X such that X is a student of second year stats. Set B consists of X such that X is any of the first 10 odd numbers. Set C consists of X such that X is any of the first 10 prime numbers. And set D consists of X such that X is a vowel. Finite and infinite sets. A set is said to be a finite set if it has a countable number of elements. For example, set A is equal to all the students of statistics at Army Barnard College for Girls, and set B is equal to months of the year. In these two sets, the number of elements are countable. whereas an infinite set is one which is not finite. That is, a set composed of countless number of elements. For example, set A is equal to the dots on the line, and set B, number of stars in the sky. In these two sets, we cannot count the number of elements, we cannot count the dots on the line, we cannot count the stars in the sky. So these are the examples of an infinite sets. Null set or empty set. A unique set having no elements at all is known as null set or empty set. A null set is denoted by the symbol phi. For example, phi is a set, a male student at a girls' college. Similarly, numbers even and odd at the same time is a phi set. Subsets. For any two sets A and B, if every element of A is also an element of B, then A is a subset of B. In symbols, A is a subset of B, or we can say B contains A. In a diagram, you can see B is a larger set and all the elements of A are also the elements of B. So B contains A, or A is a subset of B. By the definition of subsets, it is obvious that every set is a subset of itself, and null set is a subset of every set. Universal set. Universal set is a set of all related subsets and is denoted by U. Universal set is also known as a superset. In probability, the universal set is called the sample space and is denoted by S. For instance, if universal set U is equal to A, B, C, D, E, F, G, H, I, and J, the three subsets A, B, and C are: A consists of A, B, C, B consists of C, D, E, C consists of F, G, and H. These three sets are the subset of the superset U. In a Venn diagram universal set, you can see a set A and set B has some common area with element C, whereas set C is a disjoint set. Venn diagram. A pictorial way of showing sets and their relationships. The Venn diagram of two overlapping sets, they have some common area, and the Venn diagram of two disjoint sets, the two mutually exclusive events. Venn diagrams were introduced in 1880 by John Venn. They are used to teach elementary set theory as well as illustrate simple set relationships in probability, logic, statistics, linguistics, and computer science. Operations on sets. Just like addition, subtraction, and multiplication in arithmetic, there are operations on sets such as union of sets, intersection of sets, and difference of sets. Venn diagrams of set operations. Intersection of sets for two sets A and B. Union of sets, complementation of a set, and the difference of two sets. Union of sets. The union of two sets A and B is the set of all elements which belong to either A or to B or to both, and is denoted by A union B. Example, let A equal to 1, 2, 3, 4 and set B equal to 5, 6, 7, then A union B is equal to set A union set B consists of 1, 2, 3, 4, 5, 6, 7. Intersection of sets. The intersection of two sets A and B is the set of elements which are common to both A and B and is denoted by A intersection B. Example, let A equal to 1, 2, 3, 4 and set B consist of 3, 4, 5, 6, 7. Then A intersection B will consist of A sets intersection B set, which is equal to 3 and 4. These two elements are common in both the sets A and B. Difference of sets. The difference of two sets A and B is the set of elements which belong to A and which do not belong to B and is denoted by A minus B. Venn diagram showing the difference of sets. Example, let A equal to 1, 2, 3, 4, 5, 6, 7 and 8 and let B equal to 5, 6, 7, 9 and 10. Then A minus B will consist of 1, 2, 3, 4 and 8. That is, those elements of A which are not in B. We have to subtract the elements of B from A. Similarly, we can find the set of elements which belong to B and which do not belong to A and is denoted by B minus A. Here in the above example, with A equal to 1, 2, 3, 4, 5, 6, 7 and 8 and set B consisting of 5, 6, 7, 9 and 10, B minus A is equal to 9 and 10, the two elements of B which are not in A. Complement of a set. If the set A is a subset of the universal set S, then complement of a set is another subset of S which consists of those elements of S that are not in A. Hence, a complement set is also a different set, but with the universal set, that is S minus A. The complement of a set A is denoted by A complement or A bar. If A complement is a complementary set of set A, then A complement whole complement is equal to A, and A complement union A is equal to S. Venn diagram showing the A complement. Example of operations on sets. Let a superset or a universal set U is equal to 1, 2, 3, 4, 5, 6, 7, 8 and 9. Set A consists of 1, 2, 3, 4. Set B consists of 2, 4, 6, 8. And set C consists of 3, 4, 5, 6. Then find A complement, B complement, A intersection C whole complement, A union B whole complement, A complement whole complement, and B minus C whole complement. Now A complement is equal to U minus A. The set U minus the elements of set A. We are left with 5, 6, 7, 8, 9. That is, those elements of U which are not in A. Similarly, B complement is equal to U minus B. Set U minus set B is equal to 1, 3, 5, 7, 9. We subtract the elements of B from U and we are left with 1, 3, 5, 7, 9. That is, those elements of U which are not in B. A intersection C whole complement is equal to U minus A intersection C, where A intersection C is set A intersection set C is 3, 4. So we subtract A intersection C from the set U, which is equal to 1, 2, 5, 6, 7, 8, 9. That is, those elements of U which are not in A intersection C. A union B whole complement is equal to U minus A union B, where A union B is equal to 1, 2, 3, 4, 6 and 8. So for A union B whole complement, we subtract A union B from set U, which is equal to 5, 7, 9. That is, those elements of U which are not in A union B. A complement whole complement is equal to u minus a complement. A complement whole complement is equal to u minus a complement, where a complement is equal to 5, 6, 7, 8 and 9. So we subtract the elements of a complement from U set. Universal set minus a complement set is equal to 1, 2, 3, 4. That is those elements of U which are not in a complement. This set is also equal to set A. B minus C whole complement is equal to U minus B minus C set, where B minus C is equal to B set minus C set, which is 2 and 8. That is those elements of B which are not in C. B minus C complement will be equal to universal set minus B minus C set, universal set minus B minus C set, which is equal to 1, 3, 4, 5, 6, 7 and 9. That is those elements of U which are not in B minus C. Ordered pairs. An ordered pair consists of two elements, say A and B, in which one of them, say A, is designated as first element and the other as the second element. An ordered pair is denoted by AB, where A belongs to first set and B belongs to second set. Power set. The set of all subsets of a set A is called the power set of A and is denoted by P of A. The power set of the set A will contain 2 power n elements, where n stands for the number of elements in set A. For example, if set A has 3 elements A, B, C, then find the power set of A. With 3 elements A, B, C, n equal to 3, that is the number of elements of A. The number of possible subsets of A is equal to 2 power n, which is equal to 2 power n is equal to 3 and is equal to 8. The power set of A consists of empty set, set A, B set, a set with elements C, AB, AC, BC and ABC. These are 8 subsets. Product set. The product set of two sets A and B is the set which contains all ordered pairs XY, where X belongs to A and Y belongs to B. The product set is denoted by A cross B and is also known as Cartesian product of A and B. Example, let A is equal to 1, 2 and set B consists of 2, 4 and 6. Then find A cross B and B cross A. Solution. A cross B is equal to set A cross set B, 1, 2, 1, 4, 1, 6. Then 2, 2, 2, 4 and 2, 6. Similarly, B cross A is equal to B set cross A set. 2, 1, 2, 2. Then 4, 1 and 4, 2. Then 6, 1 and 6, 2. Finding Cartesian products, you should find these products A cross B and B cross B yourself with the sets A consisting of A and B and with set B consists of 1, 2 and 3. Solve and practice examples and or related questions from exercises of your book. Thank you. Have a nice day.